Hi everyone, I'm going to show you guys how to integrate this question. So what we'll first do is let's write x squared minus x plus 1 in completing square format. So this would be x minus half squared minus half squared plus 1. Now if you guys have any doubts with completing squares, please drop a comment. I'll give you guys a tutorial on that. So it's x minus half squared plus 3 over 4, right? So instead of writing x squared minus x plus 1, we could write the completing square format. So now it's x minus half squared plus 3 over 4 dot dx. So now let's take a substitution of u equals x minus half du over dx equals 1. So meaning du equals dx, nothing changes. So we have root u squared plus 3 over 4 dot du. Now let's take a substitution of u equals root 3 over 2 tan theta. Now the reason I take this substitution is you can see when I take u squared I get 3 over 4 tan squared theta, and then we could take 3 over 4 out from the root, and then tan squared plus 1 will give you sec squared theta, right? Let me just show it to you guys. We take this substitution. Now let's differentiate this. So du over dt equals to root 3 over 2 sec squared theta. So let's go back into our question. Root u squared. Instead of u squared, I'm going to write 3 over 4 tan squared theta plus 3 over 4. And instead of du, I'm going to write, so du equals to root 3 over 2 sec squared theta dot d theta. Just hold on a minute, let me take this on the right side. Yep. Okay. Dot du, which is root 3 over 2 sec squared theta dot d theta. Now let's take 3 over 4 out, so it's going to be root 3 over 2 into root tan squared theta plus 1, which is sec squared theta, and root sec squared theta is sec theta, right? So meaning that's sec theta into root 3 over 2 sec squared theta dot d theta. So now this is 3 over 4 into sec theta into sec squared theta dot d theta. Now the reason I wrote it down like this is I'm going to take integration by parts. So I'm going to take dv over d theta as sec squared theta, as you can easily integrate that, and I'm going to take u as sec theta. So du over dt, sorry, d over d theta equals, so the differentiation of sec theta is tan theta sec theta. The integration of sec squared theta is tan theta. Easy, right? Now the formula for integration by parts is uv minus the integration of v dot du over d theta dot d theta. This is your formula. So u into v, that's tan theta sec theta minus v, which is tan theta, into du over d theta. So that's tan theta sec theta, right? So this is going to be tan squared theta sec theta dot d theta. Now let's focus on the integration we have. So tan squared theta, you could write it as sec squared theta minus 1. Now that's going to be sec squared theta minus 1 into sec theta. So it's, let's write it like this: the integration of sec cube theta equals to tan theta sec theta minus, now we have the integration of sec cube theta dot d theta minus the integration of, so we had the minus over there, so when you expand minus with this minus over there gives you plus, right? So this becomes plus the integration of sec theta dot d theta. Now this term right here, you can take it on the left side, right? So that would be 2. Now sec cube theta dot d theta equals to tan theta sec theta plus the integration of sec theta. So what's the integration of sec theta? You could write it as 1 over cos theta dot d theta. Now what I would say, the best method to solve this, you could write 1 as sine squared theta plus cos squared theta, right? So that you divide by cos theta. Now this is what we need to integrate, so you could write the integration of sine squared theta over cos theta dot dt plus the integration of cos theta dot dt, right? I'm sorry guys, I've been saying a dt instead of d theta, so don't get confused, alright? So let's focus on this integral. Now the integration of cos theta is sine theta, right? That's easy, you can leave that aside. Now how do you integrate sine squared theta over cos theta dot d theta? Let's take a substitution of u equals sine theta, du over d theta equals to cos theta. So du, wait, I took u, right? So let's take w, because the previous substitution we took was u, and then we took u equals to tan t, right? We took t, and now let's take w. So w equals sine theta. dw over d theta equals to cos theta. dw over cos theta equals to d theta. So now instead of sine squared theta, you could write w squared over, instead of cos theta, you could write, hold on a minute, so I'll write cos theta dot d theta. Instead of d theta, I'm going to write dw over cos theta. So it's going to be cos squared theta, right? So if w equals sine theta, w squared equals sine squared theta, right? And you know sine squared theta plus cos squared theta equals 1. So then cos squared theta equals to 1 minus sine squared theta, right? Which is w squared. So then cos squared theta is going to be 1 minus w squared. Now when you integrate that, let's divide that using polynomial division. Minus w squared plus 1, so you have minus 1 into minus w squared is w squared minus 1, you get the remainder of 1, so it's going to be 1 over 1 minus w squared minus 1. Okay, so we have 1 over 1 minus w squared minus 1. This is what we need to integrate, and let's focus on the integration of 1 over 1 minus w squared. So that you have to break down into 1 minus w into 1 plus w. Now this feels like a never-ending question, right? So yeah, so 1, now we'll have to break this down into partial fractions. So 1 over 1 minus w into 1 plus w, you could write it as a over 1 minus w plus b over 1 plus w. Now you multiply every single term with 1 minus w into 1 plus w, so you have a into 1 plus w plus b into 1 minus w. Now you could write when w equals minus 1, b equals to minus half, and when w equals to 1 equals to 2a, a equals to half, right? Hold on a minute. When w equals to minus 1, oh shit, this should be 1 equals to 2b, right? So this is just b equals half. As you can see, 1 minus 1 in brackets, so this gives you 2, right? Positive 2. So a and b is the same value, so now it's gonna be 1 over 2 into 1 minus w plus 1 over 2 into 1 plus w. Okay, and let's put the minus 1. Minus 1 dot dw. Okay, so now it's gonna be, so the integrations of these, I don't even have to do it, you guys, it's really easy. So it's half, so negative half ln 1 minus w plus half ln 1 plus w minus w. Now if you guys have any doubts with these integrals, please drop a comment. Alright, the reason I'm not explaining that is because it's actually really easy, right? But anyways, if you guys are new to these type of questions, please drop a comment. I'll make a separate video on that. So you can write this as 1 over 2. You can take 1 over 2 out, and since you have ln functions, you can write this as 1 plus w over 1 minus w, right? Minus w. Now what was w? W equals sine theta. Okay, so then the integral of sec theta dot d theta is half ln 1 plus w over 1 minus w minus w, and don't forget we had this guy over here, sine theta, so you write plus sine theta. Now w equals sine theta, right? Is that the substitution? Yeah, w equals sine theta. So w equals sine theta, so you can write w instead over there. You can see they cancel off, and we have half into ln 1 plus sine theta over 1 minus sine theta. Okay, you could leave your answer like this, you know, this is the correct answer, but there's another form for this. You could write this is also equal to ln sec theta plus tan theta, I think. Yeah, it's also equal to that. Anyways, you could leave your answer like this. Both ways, either way it's correct, because this is what the integral gave us, right? So you write your answer like that. So now let's go back into what we had. Now we had this tan theta sec theta plus the integral of sec theta. So you write tan theta sec theta plus half ln 1 plus sine theta over 1 minus sine theta plus c. Okay, now what was the substitution we took? Now we found the integral. Oh, there's one more thing. Now we had 3 over 4 in front, right? So what we could do is we could divide all this by 2, because we had 2 in front, because it was, you can see we had 2 sec cube theta, right? And initially we had 3 over 4 too, so you can multiply this with 3 over 4, so making this 3 over 8. This becomes 3 over 8, so that becomes 3 over 8 into half, so it's 3 over 16. Now since we got this, let's go back into our previous substitution, which we took as u equals root 3 over 2 tan theta. So u equals root 3 over 2 tan theta, and we also had u equals x minus half, right? That was our first substitution. So x minus half equals to root 3 over 2 tan theta. So therefore you can write 2x minus 1 over root 3 equals tan theta. Now this, your numerator is your opposite side and your denominator is your adjacent side, right? So we need to find the hypotenuse. So hypotenuse is 2x minus 1 squared plus 3, right, in a root. So this would be 4x squared minus 4x plus 4, right, in a root. Now we could take 4 out. You could do that if you want. So let's do that. So it's going to be 2 into x squared minus x plus 1. So then you can write sine theta equals 2x minus 1 over 2 root x squared minus x plus 1, and cos theta, do we have cos theta? No, we don't. Yeah, so we have sec theta, right? So if cos theta equals root 3 over 2 root x squared minus x plus 1, then sec theta is the reciprocal of it, right? So it's going to be 2 root x squared minus x plus 1 over root 3. Okay, now let's go back into our question. So we had 3 over 8 tan theta. So tan theta is 2x minus 1 over root 3 into sec theta, which is 2 into root x squared minus x plus 1 over root 3 plus, okay, now let's just simplify. You can see these will cancel off and we have 2x minus 1 over 4 into root x squared minus x plus 1, right, plus 3 over 16 ln. Now let's put the other terms. 1 plus sine theta. So sine theta is gonna be 2x minus 1 over root x squared minus x plus 1 with a 2 over there over 1 minus sine theta. So 2x minus 1 over 2 root x squared minus x plus 1. Now we can do something over here. We can take the common denominators for the numerator and denominator. So it's going to be so we can write, instead of writing that, we could take 2 root x squared minus x plus 1 plus 2x minus 1 over 2 root x squared minus x plus 1. It's the same thing, right? And we'll have the same thing for the denominator, but the only thing that changes is the negative sign. So it's 2 root x squared minus x plus 1 minus 2x minus 1 over 2 into x squared root x squared minus x plus 1. So you can see these two will cancel off, right? And now we can just erase all that, and now you could write this as 2 root x squared minus x plus 1 plus 2x minus 1 over 2 root x squared minus x plus 1 minus 2x minus 1. So these are your answers. So this is the the simplest form you can go to. I don't think you can go any further. Let me just go through everything and see whether I did everything properly. So yeah, so that's everything for this question, and don't forget your plus C. I'll just write it on the next page. So this is going to be your final answer. So if you guys have any doubts with this question, please drop a comment. I'll help you guys out. And if you guys like my teaching, leave a like and subscribe. Have a great day.